Imagine the fastest thing you know. A race car, a jet, but nothing with mass can ever break the universe's speed limit, the speed of light. Light moves so fast it seems instant. Flip a switch, and the room is bright before you can blink. This speed, 186,282 miles per second, or about 299,792 kilometers per second, is the foundation for measuring the universe. At this speed, you could circle Earth over 7 times in a second. Our usual units, miles, kilometers, are useless for the cosmos. The numbers get too big too fast, so astronomers use the speed of light itself as a ruler. Enter the light year, not a measure of time, but of distance. A light year is how far light travels in 1 Earth year. That's nearly 6 trillion miles, or about 9.5 trillion kilometers. It's a cosmic yardstick, perfect for the vastness of space. With it, we can finally make sense of the distances between stars. The light year turns the incomprehensible into something we can measure. It's the only way to map the universe's grand scale. When you look up at the night sky, you're seeing distances measured in light years, not miles. This unit helps us understand our place among the stars. The light year is our bridge to the cosmos. It transforms the void into a space we can explore, at least with our minds. The term light year trips up many. It sounds like time, but it's pure distance. Think of it as the universe's mile or kilometer, just on a much grander scale. 1 light year is the distance light travels in a year, nearly 6 trillion miles, or about 9.5 trillion kilometers. These numbers are so huge our minds can barely grasp them. That's why astronomers use light years, to simplify the impossible. Imagine describing the nearest star's distance in miles, the number would be overwhelming. But saying 4 light years is manageable. The light year gives us a foothold to map the universe. It's essential for charting galaxies and measuring the Milky Way. Without it, we'd drown in a sea of zeros. The light year is more than a measurement. It's a tool for perspective. It reminds us that our world is just a speck in a vast ocean. Every star you see is measured in light years, making the cosmos just a bit more understandable. This unit unlocks a deeper appreciation for the universe's scale. The light year is our key to the stars. To grasp light speed, let's compare it to everyday life. Snap your fingers. Light could circle Earth over 7 times in that instant. Blink your eye. Light travels nearly the planet's circumference in that 1/10 of a second. Our fastest machines like the Parker Solar Probe reach 430,000 miles per hour, but light, 670 million miles per hour, over 1,500 times faster. It's like a snail racing a jet. That's why, on Earth, light seems instant. Phone calls, fiber optics, all happen in a flash. But space is so vast, even light's speed starts to feel slow. As we look farther out, we need new units, light seconds, light minutes, and beyond. The universe's scale makes even light's velocity look sluggish. Our technology can't compete. Light is in a league of its own. This is why we use light's speed to measure the cosmos. It's the only way to make sense of such immense distances. Light's speed is the universe's ultimate measuring stick. Before we tackle light years, let's break it down. Light seconds, light minutes, and light hours. A light second is 186,282 miles. Enough to reach the moon in just over a second. When you see the moon, you're seeing it as it was 1.3 seconds ago. A light minute is about 11 million miles. Sunlight takes about 8 minutes to reach Earth. So you see the sun as it was 8 minutes ago. If the sun vanished, we wouldn't know for 8 minutes. A light hour is 670 million miles. Neptune is about 4 light hours from the sun. Signals from Voyager take over 4 hours to reach us. These units are stepping stones, bridging familiar distances to the unimaginable. Even within our solar system, light isn't instant. We see the moon as it was seconds ago, the sun as it was minutes ago, and Neptune as it was hours ago. Looking into space is looking back in time. The farther we look, the older the light. These units help us grasp the vastness of even our own solar system, and beyond, the effect only grows. Beyond our solar system, distances become truly astronomical. The closest star, Proxima Centauri, is 4.24 light-years away. That means the light you see from it tonight left over 4 years ago. To visualize, if the Earth-Sun distance were 1 inch, Proxima Centauri would be over 4 miles away. The space between stars is a vast empty ocean. Interstellar travel is daunting because of this emptiness. When you see Proxima Centauri, you're seeing a message from the past. The light began its journey when you were living your life 4 years ago. That light has crossed the void just to reach you now. The light year helps us measure this immense gap. Our nearest neighbor is still a multi-year journey for light itself. The stars are far more distant than they appear in the night sky. The universe's scale is almost beyond comprehension. Human technology is impressive, but in cosmic terms, we're slow. Voyager 1, launched in 1977, is over 15 billion miles from Earth. At 38,000 miles per hour, it would take 75,000 years to travel a single light year. To reach Proxima Centauri, Voyager would need over 300,000 years. That's longer than modern humans have existed. Even future propulsion might only cut the journey to centuries or decades. The universe's distances are a formidable barrier. Our fastest machines crawl across the cosmic desert. The light year not only measures distance but also the time it would take to cross it. A star 100 light years away means a message would take a century to arrive. The universe is vast, and we are slow. The light year gives us perspective on our place in the cosmos. Zooming out, our sun is just one star in the Milky Way, a city of up to 400 billion stars. The Milky Way is about 100,000 light years across. Light takes 100,000 years to cross it. If a civilization on the far side sent a message, it would take 100,000 years to arrive. Our solar system sits 27,000 light-years from the galactic center. The light from that center began its journey when humans painted on cave walls. Every star you see is a neighbor in this vast city. Even these close stars are light-years away. The Milky Way's scale redefines what big means. The Milky Way is just one of billions of galaxies. Our closest major neighbor is the Andromeda Galaxy, 2.5 million light-years away. The light you see from Andromeda tonight began its journey 2.5 million years ago. Back then, early humans were just emerging in Africa. When we look at Andromeda, we see a 2.5-million-year-old photograph. We can never know what it looks like now, only what it was. The light year is a unit of distance and a time machine into the past. The farther we look, the further back in time we see. The sun's light is 8 minutes old. Proxima Centauri's is over 4 years old. Andromeda's is ancient. The universe is a cosmic history book, and every telescope is a time machine. Each light year is a page from the past. From light seconds to millions of light years, one fact remains. A light year is both distance and a window into the past. Every point of light in the night sky is a ghost from history. The starlight you see is an echo, a postcard from long ago. Looking up connects you to the past. Some stars' light began its journey before human civilization. Each star is a time capsule. The night sky is a museum of ancient light. We are tiny, but our minds can grasp these vast distances. Science and imagination let us explore the universe from Earth. Next time you see the stars, remember, some of that light has traveled longer than humans have existed. It crossed trillions of miles to reach you. That light connects you to the cosmos. By looking up, you become a time traveler and a citizen of the universe. The light year is your ticket to the stars. The universe's story is written in light, and you are part of it.